For those first couples, you have to square them first and then add them. So you would square the 3 to get 9. You would square the 4 to get 16. Then you have to add 9 and 16 to get 25. And then you take the square root of 25. In number 2, you square the negative 2 to get 4. You square the 8 to get 64. Add 4 and 64 to get 68. And then you rationalize like we did last night in the homework. So 68 divided by 4 and 17. So you got 2 square roots of 17. Number 3, you have 5 squared plus negative 12 squared. Add those together first, then take your square root. We do something similar with the variables. Okay, are there any questions on that warm-up? I know it's a little different than what we did yesterday, maybe a little more challenging in a way, but again, it's just order of operations applied with simplifying the square roots. Okay. All right, so like I said, what we're doing today is complex numbers. Complex numbers are critical in quadratics because when we talk about graphing, we talked about 3 types of graphs. You had the graphs that you had 2 real roots, 1 real root, and no real roots. The complex numbers are now our way of solving for the graphs that had no real roots. So they have roots. Those roots are just considered imaginary. So what we do is we use this value of I as this imaginary value for those roots. Or for the longest time, if you guys plugged in on your graphing calculator something like the square root of a negative number, it always gave you an error. Now we're going to learn how to take square roots of negative numbers. We're going to learn how to avoid that error. So complex numbers allow us to essentially take square roots of negative numbers. So in terms of vocabulary definition, I have the complex numbers definition. It's just on the next slide, so kind of like jump down to the next space. The imaginary unit, it's not on there. I just am telling you a unit in terms of the imaginary numbers is I squared. So if you want to put it on there, you can. But for the most part, the 2 things you really need to know is that I is considered the principal square root of negative 1. And what that means is that I is equal to the square root of negative 1. So if you see the letter I in lowercase italics in math, it means the square root of negative 1. So if you've ever been like sitting in class or you're staring at my podium and you're like, I don't get that. If you look at the background image under my name, it says square root of negative 1 hearts math. Well, that's because the square root of negative 1 is I, so it says I heart math. So I didn't make it. The student made it for me. But yes, that square root of negative 1 is the placeholder for I. imaginary numbers are square roots of negative real numbers. Imaginary numbers are square roots. They're just the square roots of a negative real number. Okay? So what does that look like? What do these definitions look like? Well, in terms of problems, if you have the square root of negative a, it becomes I square root of a. And we're going to do tons of examples. Don't worry, this is just me kind of like explaining a little bit. Or if you had the square root of negative 4, that I is the first thing you pull out, so you get I square root of 4. Then you simplify your square root to get 2i. So what we're going to do is everything we did yesterday, but now there's going to be some negatives sprinkled in underneath our square roots. So truly, it's not, if you got yesterday, you'll get today, because all we're doing is sprinkling in some negatives that turn to i's. So, by definition, a complex number is a number that consists of an imaginary and a real number. A complex number consists of an imaginary and a real number. We refer to it or see it as a plus bi. You will see a plus bi. The a is always listed first. So if it says to write it in standard form, you have to have the real plus the imaginary. So the a is always written first, and then you add the imaginary. Way back when we talked about the real number system, the complex number system is going to be everything we've talked about in the real numbers, but now we have the reals and the non-reals. So the non-reals are the same thing as the imaginary. So you might hear, like you saw me say over there, non-real roots or two non-reals. That's the same as saying two imaginaries. So the word non-real is synonymous with the word imaginary. So if you need or you like to write things down under your definitions for imaginary numbers, you could also put like a slash or the word non-reals. They're the same thing. So we just kind of talk a little bit again. The real number system, we had that same block way back when. So we had the reals, the rationals, the integers, the wholes, the naturals, and the irrationals. Now we have this non-real number system, or AKA the imaginary numbers. The reals and the non-reals make up the complex. So, it says write the complex number in the form a plus bi. So what that means is you have to write the real plus the imaginary. So the imaginary part is the part that comes from a negative square root. Right here, this is the imaginary piece to my problem. So the minute you see a negative under your square root, you want to immediately bring it out as an I. So the first thing I'm going to do is rewrite this problem as I square roots of 121 minus 7. Then I'm going to simplify the square root of 121. So square root of 121 is 11. So you get I times 11, or 11I, minus 7. The only thing is it says to write it in the form a plus bi. So what that means is I need to use the commutative property of addition and say that this is really negative 7 plus 11i. So it's the real plus the imaginary. Number 2, the square root of negative 18 plus 7. So you see that negative, we know there's going to be an I. 18 would break into what two numbers? 9 and 2. So the square root of 9 is? So you get 3i square roots of 2. So it's the same thing, it's just that now when you have a negative, you make it an I. Once again, it's not in the right order. They want you to have the 7 first, and then add the 3i root 2. Okay, negative 25 is under the square root. So what would be the square root of negative 25? It becomes good. And flip your terms. Just like we had powers of x under square roots, we can have powers of I. So the powers of I follow a pattern. We also can talk about additive inverses. What's it mean to be an additive inverse? So we talked about additive inverses way back in chapter 1. I know, I'm making your brains think real far. What's the word additive probably mean? What do you think of when you hear the word additive? What's in that word that you know? What do you think? Add. So if I see the word find the additive inverse, I'm thinking about I'm adding something and an inverse. What do we always kind of associate with the word inverse in math? So, yeah, it's like the opposite operation. So the additive inverse is what you would add. Well, I add to this to give me 0. So if I have negative 7 minus 9i, what would I add to that to give me 0? Exactly. It's opposite. I would need a positive 7 and a positive 9i. So the additive inverse is what you add to something to get 0. So what do you add to negative 5i to get 0? Well, you add to 4 to get 0. A negative 4. Add to negative 3i, positive 3i. The additive inverse of a plus bi, negative a, negative bi. Okay. The cycles of I. The cycles of I take on a pattern. The very, very first one is I. I, by definition, represents the square root of negative 1. They're kind of synonymous with each other. So I is the same as saying the square root of negative 1. I squared would be like squaring that. So if I squared the square root of negative 1, what are you left with? What would happen if you just square the square root? What happens? They cancel, right? So you're left with what's underneath. What would be underneath? That would be a negative 1. So I squared is the same as negative 1. The square root of squared of the square root of negative 1 would give you negative 1. I cubed would be like I times I squared, right? Because yesterday we said anything to an odd power is the even and then the 1. So I cubed would be like saying I squared times I. What is I squared? So I cubed is negative I. It would be like negative the square root of negative 1. I to the fourth. What could you make I to the fourth? What 2 do we already know? It would be I squared times I squared, right? We know I squared, so 2 times 2 gives you 4. What is I squared? I squared is negative 1. What's negative 1 times negative 1? 1. The cycles of I repeat every 4. So what that means is after I hit I to the fourth, I go back to being the same as I, which I is just I. So I to the fifth is I. I to the sixth would be negative 1. I to the seventh is the same as I cubed, which is negative I. I to the eighth is the same as I to the fourth, which is positive 1. These right here are what you need to memorize. The I, the negative 1, negative I, positive 1. Because any power of I, like these examples down below, can be rewritten using one of those 4 values. So if you ever found that's higher than 4, you know you've got it wrong. So I to the 13. What we're going to do to solve these is you want to find the multiple of 4 closest to the number you're looking at. So I to the 13. What multiple of 4 is very close to 13? 12. It has to be less than. So you're going to rewrite this like I to the 12. How many remain from 12 to 13? Times I. The reason I want multiples of 4 is because all the multiples of 4 are going to be 1s. So I to the 12 becomes a 1. So what am I left with? Just good. So I to the 13 is really like I to the 11. What multiple of 4 is near 11? But less than 11. So it can't be over it. 8. So I to the 11 is 8. How many between 8 and 11? So I11 is kind of like I8 times I3. I8 is always I cubed is, so I to the 11 is negative I. I to the 91. What's a multiple of 4 near 91? 22. Keep going. We gotta get way closer to 91 than 22. Okay. 88. Yeah, I was like, you divided. I was like, 4 times 22 is 88. I was like, I see where you're going. Yeah. I to the 88 is the closest multiple of 4 less than 91. How many are left behind? Yeah, 3, which gives me negative I. About 244. Yeah, exactly. So wait, 244 is a factor of 4. Therefore, this is like I to the 4th. Therefore, your answer is 1. I to the 10th. So you're going to look for that factor of 4, which is 8. And then you have 2. So 8 becomes a 1. I squared becomes, so you get -1. If 2 i's are being added, you have to do them separate. It's like variables with x's. X to the 6th cannot be added to x cubed. So you have to do I to the 6th and I cubed. So what is I to the 6th? What is I cubed? So you have -1 minus I. Real plus imaginary. I just want to do 4 more examples with the square roots not adding a number. So what's the square root of -54? First thing you want to do, the negative becomes in. 54 is what 2 numbers multiplied where 1's a perfect square? 9 and... So square root of 9 is, we have 3i, square root of 6. Square root of -2, the I takes on the negative, we get I square root of 2. Can't simplify root 2. Okay, 12. Bring out your negative for the I. You get 4 times 3. Square root of 4 is 2, so you have 2i square root of 3. So, bring out the I. What about 36? What happens to square root of 36? Yeah, so you just get 6i.